first things first. We have a circle, very lopsided one. Okay? If I start here and I go all the way around the circle, right? How many degrees have I created? How do I make? 360 degrees, right? Well, what is the actual distance around this circle? If I said that this was 1 unit, okay? How do I find the distance around a circle? Okay, and what is my circumference? How do I find it? What's circumference of a circle?
R squared.
That would be area. 2 pi r. Very good. So if I state then that my radius is 1, that means I go 2 pi radians around the circle. So that distance all the way around this circle is 360 degrees, or 2 pi radians. And radians is the arc length. Okay? It's another way in which we can measure an angle. I like to assimilate it to kilometers and miles. All right? So 360 degrees is 2 pi radians around the circle. So what is halfway around the circle then? How many degrees? 180? And how many radians would that be? Pi radians. Okay? So we are going to use that conversion to change from degrees to radians and radians to degrees. All right? So, for example, 30 degrees. Well, if I look at my circle, I always start with the x-axis, and every angle that's measured in that first quadrant, if you remember last year, is called the reference angle. So anytime you get an angle in the first quadrant, we refer to it as our reference angle. That angle will always be made with the horizontal axis, with the x-axis. So if theta here is equal to 30 degrees, and I want to find out that distance right there, okay? To find out that distance, I'm going to make that distance S, all right? Okay, so S is equal to the angle in radian measure times the radius. So this is what we call the arc length. So this is the very first thing that we need to do today that's new to you. This is called arc length. Arc length is this distance from here to here. Okay? In order to find the arc length, we need the radian measure. To get the radian measure, I change 30 degrees to pi over 180 degrees. That's my ratio. That gets rid of the degrees and leaves me with radians. 30 pi over 180 reduced is pi over 6 radians. Okay? So there's again something we looked at last year. I just multiply by my ratio. So if I want to change it from radians to degrees, I just flip this ratio. All right? Pretty straightforward concept so far. Now, if I wanted to find that arc length, it would depend on how long my radius is here. Okay, we are going to primarily deal with a radius of 1 unit. But just for the heck of it, let's say that it was 5 units long. Let's say that that was 5 units long. So then I could measure what this arc length is by taking pi over 6 radians and multiplying it by a radius of 5. So how long is this arc length right here? 5 pi over 6. Okay, and depending on what the units were for this, that's what the units would be. Whether it's centimeters, meters, millimeters, whatever it is. Okay, so the first thing that we do that's new to you is this today. To find arc length, we take the measure of this angle in radians, not degrees, okay, and we multiply it by the radius. All right. So 2 words. This one is the first one. This is reference angle. The reference angle is always the one made in this quadrant. We need that reference angle because when we look at all of the other angles that have the same ratios, all right, meaning that this length and that length are the same as this length and over here, okay? That's called the reference angle. We need that. So the reference angle is the one always made with the x-axis. Again, this is all stuff that's not new. We did this last year. We'll work with it a little bit longer. There's a second word that you want to know today that's new to you. Coterminal. Coterminal simply means an angle with the exact same position on the circle. So what other angle has the exact same position on the circle? Well, if this angle is 30 degrees, I want another angle measure that is in the exact same position. So how do I get there? Well, let's add 360 degrees to it. Let's subtract 360 degrees to it. That takes you back to exactly where you started, but gives you a different angle. So if I go 360 degrees forward, an angle coterminal to 30 degrees would be 390 degrees. Okay? If I went backwards 360 degrees, I always start my measurement with this line here. So I'd actually only be going from here around to here. What is that angle as a negative? Because if you go in the opposite direction, what is that angle as a negative? Negative 330. That's also coterminal. And that's just because I subtracted 360 from my original. Okay? So those are the two new things that we didn't do much with last year. All right, look on page 110 now. So today's first part is draw the angle in its standard position, convert each degree to radian and each radian to degree, and give answers as both exact and, if necessary, approximate answers, measures to the nearest hundredth of a unit. I would go to a thousandth of a unit because that's what the test paper will ask you. Here's the thing, okay? Exact value means that you leave the pi value as part of it, okay? Just like if I said a radical, we leave it as an exact value, the square root of 3, we don't round it or approximate it by taking it onto the calculator and punching it in. We just leave the square root 3 as the value. You do the same thing with pi. So for example, the first one is 135 degrees. Well, where do we find it? We start here and we work our way this way. Up to here is 90 degrees. All the way to there is 135. Right? So I basically look at it as this is a hand, and I just move it until I hit to 135 degrees. So now I want to write that 135 degrees. I want to change it to radians. So I go pi over 180 degrees equals 135 over 180 is what? Is that an exact value? No. What do you got?
135 pi.
Yeah, now, okay. Let's use your calculator for this just one time. Take 135, divide it by 180. But you need to get this in your mind, what we're doing here. What is it? Math, fraction. What is it? 3 pi over 4, exactly. That's an exact value. That's what we are looking for now. 3 pi over 4. Well, think about it here for a second. How many degrees is it from here to here? If this is 90 to here, how many more degrees is it? 45, correct? From here to here is how many degrees? 145, 245, 345s. 445s get you to there, so you've got 3 over 4. Right? That's a different way of looking at it. Okay? So, there you have it. 3 pi over 4 radians That's 135 degrees. 5 pi over 6 now. 5 pi over 6, okay. So this is where we have to start really doing some thinking as to how this breaks down for us. Okay? So the first thing I would do right now, until you get really good at this, and you will, okay? 5 pi over 6. All right, let's change it to degrees so we know where to draw it. So how do I change it? What's the ratio now that I multiply by? What's that? No. What's the ratio that I have to multiply it by in order to change it from radians to degrees? What was the ratio I used to times by 135 to get it from degrees to radians? Pi over 180s. Okay? So what is it, the ratio going to be now? 180 over pi. 180 over pi. You flip the ratio. If I was changing from centimeters to meters, and then meters to centimeters, all I do is flip the ratio in order to get there, right? We've done lots of this. Okay? So what is this then? Oh, pi's cancel. 180 divided by 6 is 30. 30 times 5 is 150 degrees. Okay? So where is that located? Right here. What's my reference angle right here? What's the reference angle right there? 30. Agreed. Okay, now I want you to think about this. All right? This is 1 pi. We understand that as radians, right? 180 degrees is 1 pi. How many 6's do I have in 1 pi? 6 of them. So 5 pi over 6. This we just said was 30 degrees, right? There's 1 pi over 6. Here's 2 pi over 6. Here's 3 pi over 6. Here's 4 pi over 6, so that would be 120, right? Here's 5 pi over 6, 150 degrees. We are going to exclusively change this unit circle into 6's, 4's, and 2's. We're going to work with 30 degrees, we're going to work with 45 degrees, or we're going to work with 90 degrees. And that's it. That's all you need to be concerned with. Okay? C now. C has a value of 4. Do you see a degree symbol on it? No. So what does 4 represent? It's not degrees, it's obviously radians. Okay, so this is the one now where we have to make more sense of this. I want you to think about this for a second. If I were to convert pi to an actual value, what is the value of pi? Approximately 3.14, right? And it goes on forever because it's an irrational number, right? So 3.14. Okay? So then is 4 greater than that or less than that? It's greater than 3.14, right? So I'm thinking that that 4 value must be somewhere in here. Maybe go as far as over here, but somewhere probably around here. Well, let's find out. Let's change that again to degrees. So 4 radians is 180 degrees over pi. Now you can use your calculator. Now you can find out the value of it. It's not going to be an exact value. You need to now punch it into your calculator. Go ahead. To 3 decimal places, what do we get?
229.183.
229.183, and now we have degrees again. right? How many degrees is pi? 180. Add 49.183. There's my angle down there. 229.183. Okay? The thing that throws all math students off is when you see 4. You don't associate it because we're going to spend so much time working with pi values, we don't associate 4 with an actual measure of a radian value. And it is. If there's no degree symbol on it, then it's a measure in radians. So you need to convert it by taking 180 over pi and putting it there. Fair enough? Any questions so far about that? So all you've looked at so far is converting, right? All you've looked at so far is just converting. Radians to degrees, degrees to radians. We did that last year. Okay, we didn't need to last year, but we did it last year because this is what we're going to do this year. So that's why we did learn it last year. Last year we worked with that unit circle and we only did degrees. But we did see this because now, instead of using degrees, we'll use radians all the way around, and it's exactly the same as what we did last year. Okay? Look at example 3. The ring road around eastern part of the city of Regina is almost a semicircle. Estimate the length of the ring road if the radius of the circle is 4.9 kilometers. Okay, so what are we looking for? The ring road, it looks like you're going from Pasqua to Louvain.
Excuse me for the interruption, Mr. Wilson, call 50,000, please, Mr. Wilson.
We would come in on Victoria Avenue. And so going from Louvain to Pasqua, all right? So, they got Louvain down here, okay? They got Pasqua up here in the north end, all right? And it looks like this, okay? Here's Victoria, that's the eastern road, that's Highway 1 coming into Regina. And then you have the ring road. So to go around the city and avoid everything, used to be the way to go, but now it's not. Anyways, here's what we have. So what I want to do is I want to find out then, what is the distance from the end of Louvain to the start of Pasqua, or to the end of Pasqua. It's not even the end, it's the middle of Pasqua. Pasqua goes north. So from the end of Louvain, up by the airport, to Pasqua up here. Okay? And what do they give us? They give us a radius of, what is it? 4.9 kilometers? Okay? And we are given 2 angles, right? From Victoria to here is 97 degrees. And from Victoria to Louvain is 110 degrees. So what am I looking for? I'm looking for this distance here. What do we call that distance? What do you call that partial distance around a circle? No, circumference is the whole distance around the circle. What is it? It's the arc length, right? We just learned about this, the very first thing we did today. S. So we want to find out what that distance of arc length is. We need theta in radians times my radius. So what's the first thing that we need to do then? Convert the degrees to radians. So we have 207 degrees, and we need to convert it. So what's my ratio to go from degrees to radians?
Out of curiosity, when it says negative around 10 in the book, does that mean anything
No.
other than it's in the bottom?
Other than they measured it going the opposite way from your x.
Okay.
Yes. So the total arc length is 110. Okay, but that's good to pick up. Okay, again, notice that they measured this distance right here as a negative because it was on the other direction. Okay, positive is always counterclockwise. All right, so what is the ratio I multiply by? Pi over 180. So punch that into your calculator and give me the value, please. To 3 decimal places.
3.623. 613.
3.613.
613.
Everybody agree? Have we rounded that correctly? Okay, perfect. So then we go 3.613. There's my angle and radian measure multiplied by 4.9. And what is that distance from A to B?
17.703.
And we put our kilometers in there. There you go. That's all there is to it. Okay? One last thing. One of the things that they will do when it comes to this provincial exam, they will tell you exactly what they're looking for in terms of their solution, whether it's in degrees or whether it's in radians. So if they give you a domain that looks something like this, minus 2 pi less than or equal to theta less than or equal to 2 pi, that means your solution has to be in radians. If they give you a domain of minus 720 degrees less than or equal to theta less than or equal to 720 degrees or whatever it is, then that means that your answer has to be in degrees. Okay? So they will specify that at the top of a question. And then if they say general solution, they mean radians. They say all real numbers, they mean radians. In grade 11, you deal primarily with just degrees. We introduce radians, but we just do degrees. In grade 12, we work with just the radian measure. Again, it is still the same thing, except you're just changing it to a different measurement value. Okay? All right? Okay, sorry, I'm just going to see where we have to end up this week. 4.
Everybody here to write the test on Friday?
Yep. 4.3. So we have 4.2, 4.3. Okay, one last thing I'm just going to quickly go with you. Just show you, just to, so that tomorrow is a little bit smoother. We talk about ratios, angle ratios. When we do trig in grade 10, we always say, okay, well, we figure it out ourselves what sine, cos, and tan is, right? So it's opposite over adjacent, opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent, right? Well, what we tend to forget is that we are comparing the lengths of sides of triangles. All right? And when we find the sine of an angle, we're finding out what the ratio of the longer side, or what the shorter side is to the longest side of the triangle. Okay? When we do that, we can come up with values that are very specific. This is the one that we always had to remember last year, and basically from grade 10 on, in fact. If I'm talking about 30 degrees in a right triangle, what is the sine of 30 degrees? This is the one you were told you absolutely at all times had to remember. What is the sine of 30 degrees? I'm asking you what the ratio of the side, the opposite side is to the longest side, the hypotenuse. 1/2, 0.5, right? So when I write that in as 1/2, my sine of 30 degrees has a ratio of 1 to 2. My cos of 30 degrees then, what's the cos ratio? Well, we need to find this side length right here. And using Pythagoras' theorem, Okay, this side squared plus this side squared is equal to that side squared, right? 2 squared is 4. 4 subtract 1 is 3. The square root of 3 is the length of this side right here. So if I know that the square root of 3 is that length, then I just use Pythagoras' theorem to do it, right? What is the cos of 30 degrees then? The ratio is the square root of 3 over 2. What is the tan of 30 degrees? Pardon me? 1 over square root 3. Okay? And we would, in years past, we would rationalize that times the top and bottom by root 3 over root 3. And we get root 3 over 3. But for right now, you don't need to worry about rationalizing. But on this, using this same idea and premise, what is the sine of 60 degrees? What is it? Root 3 over 2. This triangle right here is going to be massively important to us moving ahead. We have to remember these. We have to be able to instantly calculate these ratios. Okay? Cos of 60 is what? 1/2. And tan of 60 is root 3 over 1. Those ratios are going to be massively important to you as we move ahead. Okay? What happens if I do this? Determine the missing coordinate for each of the following points on the unit circle. Point A. I want to find the missing coordinate, part of the coordinate. I want to find out what y is. And the value is found in quadrant 2. So, how do I find out what y is? Okay? Here's what happens. I know this is in quadrant 2, correct? And I know I'm looking for the y value of that coordinate. This value right here represents the cos of the angle. Okay? So, drawing that out, then that means that this is minus 4 over 5, adjacent over hypotenuse. Fair enough? We're still learning. We don't know that this is the cos of it yet. This is one way to do this question. So this is where we're going with this. Okay? What is this value right here? Quick, 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 quick. What is that value? All right. We have a right angle triangle. What is another name for a right angle triangle? What's another name for a right angle triangle? Anybody know?
The Pythagorean one.
Yeah, what is it though?
I don't know.
What are the 3 smallest numbers, whole numbers,
3, 4.
that support Pythagoras' theorem? This is also known as a 3, 4, 5 triangle. That side has to be 3. We don't need to overthink this. It's that simple. What is the value of y then if I told you that it's the sine ratio? What is it? Yeah, it is. If this is the cos ratio and this is the sine ratio, then y is 3 over 5. Okay? So that's where we're going with this, but here's actually the way they want you to solve it, because you don't know that yet. So here it is. Okay? This coordinate here is minus 4 over 5 and y. Now if I apply this to the unit circle, that means that my radius on the unit circle is 1. So I'm going to redo this. This distance here is 1. This coordinate is minus 4 over 5 and y. All right, which means that my x value is minus 4 over 5, correct? And that's my y. That's x, that's y. So the distance from there to there is x, obviously. Distance from here to here is y, we agree? So now if I use Pythagoras' theorem, that squared plus that squared equals that squared. Agreed? So I have minus 4 over 5 squared plus y squared is equal to 1 squared. 16 over 25 plus y squared is equal to 1. Subtract that to the other side. Y squared is equal to 1 minus 16 over 25. What's the common denominator between 1 and 25? 25. So that becomes 25 over 25, right? What's 25 subtract 16? 25 subtract 16?
9.
Thank you. And what's the square root of 9 over 25? Also 3 over 5. Those are two ways in which we can get that answer. Okay? All right. Today you need to complete to the end of 4.1 for tomorrow's class. And if you notice, go to page 119 for a second, please. You need to start thinking this circle through. As much as it pains me to say this, you are going to need to memorize that circle. You will understand it because you're going to use it so frequently in the next 3 units that it'll be nothing to do to memorize it. Don't take it home and just study it and look at it and memorize it. You'll just work with it so much that you're going to get it. Okay? Within reason, of course. All right?